Thank you so much, and thank you so much, everyone, for being here. You know, Lagrange was one of the first companies to really begin to commercialize technology at the intersection of AI and zero-knowledge proof. And it warms my heart to see such a large focus of the space on verifiable AI, but intellectually honest verifiable AI. Not verifiable AI designed to launch a token, or verifiable AI that has some consensus of validators that are generating an excuse to launch a token, but intellectually honest verifiable AI secured by cryptography. And I hope nobody here minds me saying that Lagrange is the company that is at the frontier of verifiable AI. From independent benchmarks, DeepProve is 1,000 times faster than our closest competitors. And we've been very fortunate to be able to actually prove frontier models like GPT-2, which we announced previously. And today, we're excited to announce that DeepProve has reached a new milestone and set a new benchmark for verifiable AI. As of today, Lagrange can prove Gemma 3, the frontier model from DeepMind, that is open source at least, and we can prove that in a set of benchmarks that are commercially viable, and we believe open up a new frontier of applications for verifiable AI outside of crypto. For the first time, you can take a popular LLM, one that you might actually use in a Web 2 context, and you can make it private and you can make it verifiable in a way that lets you use it in security critical settings. Now, let's start with a very simple question. Why does proving AI even matter? We have a whole day dedicated to it today, and we have about 4 or 5 companies that are making a stab at trying to do it. It matters because AI is the foundation of intelligence systems in security critical industries, all the way from aerospace defense and kill chain relevant autonomous weapons, all the way to healthcare and diagnostic models. The use, please go back, yeah. The use of AI within security critical settings is only expanding. And the only way to ensure that it operates such that consumer preferences and security principles are protected is through advanced cryptography. Cryptography secures the modern internet, TLS over HTTP. The foundation of everything that we rely on in the modern internet, from e-commerce to online banking, is protected by cryptography. And naturally, the only way to ensure that AI systems at the frontier of machine intelligence have the same properties of security and privacy is through building cryptographic systems to protect them. Next slide, please. Wonderful. So what does ZKML actually solve? Very broadly, there are 4 things. Firstly, accuracy. How do I ensure that the model in question, with respect to a given input, has produced a certain output? How do I ensure it hasn't been tampered with? How do I ensure that it is audible and that there is a chronology of that inference? Number 2 is safety. How do I ensure that if I use this output in some system that has large-scale downstream ramifications, think of autonomous weapons, healthcare, really anything within enterprise finance, how do I ensure that that AI input that is being used to change some property in another system has correctly originated from the right model? Then number 2 is integrity, and number 3 is integrity, number 4 is privacy. Privacy is a big one, right? How do I ensure that sensitive consumer data isn't leaked to large cloud providers or data aggregators? How do I ensure that if a hospital is using an LLM to diagnose a common illness, that there isn't a third party who can take that data and resell it? ZKML is a technology that allows that to be solved in conjunction with things like MPC and FHE. Now, today, as I mentioned at the beginning, we have extended our library DeepProve to be able to support Gemma 3. The first time that any company building ZK machine learning systems can actually prove a frontier LLM model. We can do this through massive improvements to the underlying infrastructure and massive efficiency gains through parallelization and GPU optimization. And we can do this now in settings ranging from healthcare to defense to enterprise AI to crypto. So for those of you who are interested, I recommend you check out our GitHub library where you can take Gemma 3 and run it through the model. So you can take Gemma 3 and run it through our prover and generate proofs of correctness of the output, which allows Lagrange to effectively be a verifiable AI layer for all of crypto and for all of Web 2 applications as well. This is a fundamental breakthrough. We've seen ZKML systems for the last 3 years operate as little more than science projects. They're hackathon curiosities, and they are intellectual experiments created in university labs or early stage companies seeking their first rounds of financing. Lagrange launched a token earlier this year. We are one of the largest ZK companies in the industry, and we are the only company that has commercially been able to advance ZKML to the production level. We've announced fantastic works earlier this year with teams like Intel and NVIDIA, and I recommend everyone here stay tuned for some very large commercial announcements in emergent sectors over the next few months. But the backbone of this is our ability to prove frontier LLMs like Gemma 3. What makes Lagrange different? The last milestone we demonstrated was GPT-2, which is an older model architecture, but we claimed at the time was a sign of Lagrange's ability to very soon prove the frontier. And today, we show that prediction is accurate. Gemma 3 being Google's frontier open source model, or frontier open source LLM, and today we can prove it. Today you can take a real world application all the way from a chatbot that you use for consumer financial payments in a bank, all the way through to a complex decision model that you fine-tuned within an autonomous drone or autonomous warfighting system. And you can add verifiability and privacy on top of it. Excellent. This required a rather substantial improvement in the core infrastructure. We had to take the DeepProve library and effectively double the number of parameters that we can prove. For the current benchmarks that we have released online, Lagrange has been able to prove Gemma 3 and the 270 million parameter version of that. This required us to embrace new levels of parallelism and new levels of GPU architectures, as well as to build a variety of new modules, write circuits for a variety of new modules within our Onyx representation that we use for proving models. This required things like group query attestations, attention layer for global and local orchestration, rotary position encodings, root squared mean norms, and gate linear units. For the sake of brevity, and not to bore everyone here, we won't go into each of these, but I recommend you read our blog, which will be published concurrently with this talk, for those of you who are interested in these technical fundamentals. But to summarize, what this means is verifiable AI is here. Not verifiable AI with some scammy token staking, but verifiable AI with cryptographic security. The same type of cryptographic security that protects the web, internet payments, e-commerce, and the foundation of modern blockchains now protects AI. We're going to be announcing soon some very, very large partners across healthcare, enterprise AI, and aerospace and defense who will be embracing cryptographically secured AI at the frontier. And the frontier of industries that are security conscious outside of crypto. So what's next for DeepProve? Well, we're going to continue to expand the LLMs and model architectures we support, all the way from computer vision and drones to other commercially frontier LLMs, things like Llama, Falcon, Mistral, and more. Expect more announcements surrounding this soon. And for anyone here who is potentially building something that requires cryptographically secured AI at the frontier, feel free to reach out to us. Our team is happy to help, and our team is happy to provide developer grants. Now, what I want to end with today is that the applications of verifiable AI and cryptographically secured AI specifically are not just crypto. There is a tendency to try to build technology for peer problems. When you look around crypto, there's a bunch of persistent problems that our peers are trying to solve. And the majority of companies going after them have yet to look at what the largest market for their technology is. We've spent about $1 billion as an industry building ZK for launching new tokens and making blockchains faster. It is an uninspired and rather small and limited application of what is a fundamentally new paradigm for securing computation. Lagrange believes that that is the old way of thinking. That is the past. We already have dozens of ZK rollups and dozens of ZK rollup teams that have had various levels of commercial success. What the frontier of cryptography is taking what has been financed and developed in crypto and applying that outside of crypto. Bring that to enterprise AI, bring that to healthcare, and bring that to aerospace and defense. Lagrange is the company not just building the future of cryptographically secured AI, but we're the company that is commercializing that within sectors that crypto companies have never entered before. If that excites you, reach out to our team, build with us, connect with us, and learn more about what we're doing. Thank you all for coming here today, and I look forward to seeing what many of you build on top of our technology.